ChatGPT.
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 ChatGPT. Maybe you've heard of it.
Some say it's a threat to society.
Concerns are pretty stark, actually.
Quite alarmed.
This is a monster.
We're led to believe that ChatGPT is the beginning of a big bad AI that will cripple the human race. While some of these concerns are valid, others cannot be further away from reality. But for now, it's just a language model, a sophisticated model, but I believe the subject deserves some demystification. Let me explain how it works and how it was trained in simple terms with clear examples. It might feel that ChatGPT understands what it says because it comes so naturally and confidently, but it really doesn't. All it does is it produces the next most likely word after the previous word based on lots of text data it was trained on. So for example, a very simple example, if all the text data that a transformer model was trained on would be this text, and you can pause to read it, and say we wanted this model to answer something if we input just a single word "the" into the prompt. Then just by looking at the examples in this dataset, the model can see that after "the" there can only be week, crab, house, curtain, party, bag, and the word house is twice as frequent as any other word. So statistically, after "the" goes house, and this would be the output of this transformer model. As you can see, this is not artificial intelligence, self-awareness, or magic. Straight up statistics. But in the case of ChatGPT, it has been trained on a good chunk of internet. The amount of text examples and different combinations of word sequences it has seen is much more than any human can imagine. That is why interaction with ChatGPT is so natural you can't believe it's real. Now let's look into the interesting details. So how exactly is it trained? First of all, a machine learning model cannot be trained on text. A machine understands only numbers. Hold on to this thought for now. We'll break down ChatGPT training into two major steps. Pre-training, which is creating a sequence model that can predict the next most likely word based on previous words, like in our example above. And fine-tuning, which is transforming our sequence model into a chatbot, which can interact with the user just like ChatGPT does, providing longer and more meaningful answers to the questions in a dialogue format. Now let's look at these steps. First, a dictionary is defined, which contains all the possible words. There is a distinct number of words in a language. All the individual words are assigned an individual number, and we can say the words are encoded by numbers. For example, if our vocabulary consisted only of these 5 words, then their encoded numerical representations would be 0, 1, 2, 3, and 4. 5 words, 5 numbers. A dictionary used by ChatGPT by pair encoding tokenizer is slightly larger and contains 50,000 unique subwords. What is a subword? Well, a word car, for example, is complete and can be encoded by one unique integer, say 15, whereas a word cars contain 2 subwords, car and s, and this word will be encoded by 2 numbers, 15 and whatever is reserved for s according to the dictionary, say 7. Now that we have a dictionary that contains all the possible words and their corresponding numerical codes, we have to encode our training data like this. All these words are encoded with their corresponding numbers or embeddings. This is our small example. OpenAI has trained its model on 8 million documents with over 10 billion words, and this is how they were encoded. So how can we now use this data to train a transformer model? It's prohibitively expensive to train a model like ChatGPT on such a huge data set. So the training data is split into blocks. Let's sample one block from our dummy dataset. This block has multiple examples packed into it, because all these words follow each other. So during training a model on this sample, it's going to simultaneously learn to make predictions at every one of these positions. Let me explain. In the context of I, went comes next. In the context of I went, to comes next, and so forth for each of the sequence combinations in this block. Given all these examples within this block, the model will be able to generate the whole sequence based on just one first input, I. This is made possible due to the attention mechanism concept, where each example contains the context of each of the previous examples within one block. We have a small block of 17 words, which hold a certain context. In larger systems like ChatGPT, these blocks are much bigger, about 3,000 words, thus giving the network much more context to predict the next possible word in a sequence. From this one block, we have 16 training examples with their 16 corresponding labels. A number of blocks like this form a batch, which is fed to a machine learning model for a training iteration. Now, here's an overly simplified explanation of how a neural network is trained. just to show you how much magic is really behind deep learning. Here is our training data with labels. A neural network needs to learn a function that will derive the output based on inputs. For each of the inputs, it will randomly assign weights or multipliers. Initially, these weights are random. During training, with the first neural network forward pass, it would multiply the inputs with their weights, add them up to provide the intermediate output. Then this calculated output is the current neural network prediction. And since we know the ground truth for this particular sample, we can compare the prediction to the ground truth. Here we can see that our predictions are way off from the ground truth labels, just mathematically. This is measured through a loss function, or in other words, a prediction error. So how can the network learn from this to provide better or closer to the ground truth predictions? Well, the only thing in our control within this function is the weights values. Through a backpropagation mechanism, we can adjust the weights so that with the next forward pass, we achieve a lower error. And with enough iterations, we can refine our weights so that with a given input, it will predict an output much more accurately. I'm deliberately omitting all the multiple underlying operations within forward and back propagation passes, all the metrics, multiplications, and other implications, in order not to distract you from the point. Training a neural network is just repeating the same operation over and over again. As you can see, this is a simple concept. The neural network essentially makes an uneducated guess by creating random weights or multipliers, then mathematically adjusts those weights. It doesn't understand the meaning of the data or the target it's training to predict. It juggles the numbers to learn the function and reduce the prediction error to the minimum. Okay, so hopefully now we have a pre-trained model that can predict the next most plausible word based on the provided context. But this model cannot answer the questions like ChatGPT does, yet. So what is behind the fine-tuning process? This step encapsulates the most effort and expertise and is the most labor-intensive. It requires different type of data, which consists of example questions and example answers in dialogue format. This dataset is much smaller than the one used in the pre-training stage, because this time it actually has to be handcrafted by humans. Later in the process, a model would output several different answers to the same question, and a human would rank those answers and feed the ranking results back to the training pipeline. After a lot of fine-tuning and engineering, this system is not a single model anymore. It now has the capabilities to generate not just words, but whole passages of meaningful text. It understands sentiment, it can summarize documents, it has named entity recognition capabilities. Its responses are filtered and censored based on hard-coded specific social guidelines. It is ChatGPT. I've tried to describe it in the simplest terms possible, but don't get me wrong, it is a state-of-the-art engineering effort backed by Microsoft's multi-billion-dollar investments and supercompute power. But it still is a language model for now.